Hi, I'm Venkana, dealing with the subject design of machine elements. In this subject, introduction. In this introduction, the main objectives are understanding the basic requirements of design and definition of the design. This means define the term design and identify the factors governing design. Now, here in this case, what is meant by design first of all, and then why design is to be done, how it can be done. Now let us see the definition for design: a process of formulating a plan for achieving a useful product. This is the definition. That means in order to get a new product, we are going to have a plan that is to be formulated. That is called a design. And what is the need of design here in this case? Why we have to carry out the design? Basically, the man needs something. So the need of a person or human needs design of the product, and the desires also leads to the design of a product, and ambitions of man leads to design for a particular product. So this is the need. It means need of a person, desire of a person, ambition of a person leads to design for a product. So since the evolution of man, he needs food for his survival, so that generally he designed tools for hunting. Then he want to swim like a fish on the water. Then he designed something to move on the water. And similarly, he designed and developed a means for traveling over the water. Here the ships, boats, etc. they have designed. And he wants to lift the loads, etc. In such cases, he designs something. We have bullock carts, etc. And also for lifting, these are the pictures regarding this. And also, the man wants to move faster on the roads and water, air. He developed many means for transport. So here in this case, on roads, cycle, bicycle, and then cars for transporting the goods, lorries, and transporting of human. These are the buses, etc., and trains. Whereas for moving on the water, he designed ships, etc., and also for moving on the air, he designed helicopters, aeroplanes, etc. And now these are the, he want to fly like a bird. He invented helicopters, aeroplanes, etc. Now in the design, what are the design methods? Here traditional design methods are mainly design by craft evaluation and design by drawing. These are the two methods for design. Now here in this case, design by craft evaluation, just like in our villages, bullock carts, rowing boats, plows, and musical instruments also developed by craft evaluation. And the main features of the craft evaluation are no dimensional drawings of the products and no adequate justification for design, and products developed by only trial and error methods. So no medium to record and manufacture and assembling techniques in this craft evaluation, and hence the design by craft evaluation becomes obsolete nowadays and leads to development of design by drawing only. Now here the second method is design by drawing. Salient features in this design by drawing are: drawings are developed prior to manufacture, that means before manufacturing, and intellectual activity, that means scientific designing, is assigned to design engineers, and also trial and error conducted only drawings instead of shop floor, and manufacturing process is subdivided into different areas. These are the design by drawing methods. And similarly, modern machine design was developed on the foundation of design by drawing. Whereas in the previous case, the obsoleted is designed by craft evolution. Nowadays, we are going to have design by drawing. Now, what is meant by the machine design? So, machine design is creation of new and better machines. And also, the machine design is the improving the existing ones. First one is creation of new and better machines, and second one is improving the existing ones. And this machine design is also called mechanical engineering design. Now, in this case, the machine design is intended to develop products which are safer to the human and more efficient in case of working, and comfortable to the human and economical also. Now, the machine design is defined as the use of scientific principles and technical information and imagination of men or machinery or the system. The definition for in this case, formulating a plan for achieving a product by using scientific principles, technical information, imagination of a machine or the system. This is the definition for machine design or mechanical engineering design. Now, as per the definition, the machine design needs engineering drawing, mathematical information, and engineering mechanics principles, and strength of material principles, theory of machines principles, and workshop technology. All these information, that means knowledge of all these subjects should have for a machine design, for the design of any machine or any product, because machine design. The machine design mainly develops to perform specified functions with maximum efficiency and economy. This is the function. Now the classification of machine design. In case of classification of machine design or mechanical engineering design, these are the three categories. Number one is adaptive design, number two is development design, and then new design. One is the adaptive design, and second is the developmental design, and third one is the new design. Let us see what is the each one. Now here in this case, adaptive design. In case of adaptive design, the designer makes minor alterations. That means already in the existing design, slight modifications, minor modification in the existing design of the product. That means already existing product can be slightly altered and changed. So use of fiber body instead of metallic body in automobile industry nowadays. So this is the adaptive design. And nowadays most of the people are using this adaptive design. And now developmental design. That means modifying the existing designs into a new, adapting a new material or different method of manufacture in this case. It means the existing products are slightly modified by new adapting new materials or new different methods for the manufacture. That means example here in this case are introduction of cell phones in place of land phones. That means land phones are mainly intended for talking, whereas the cell phones also main function is talking with each other. But here in this case, cell phones will have additional features instead of land phones. Land phones only wire phones, whereas the cell phones are wireless phones. And here in the cell phones, there are so many features are there. You can have, that means the land phones are obsoleted, whereas the cell phones are nowadays invented, developed component. So developmental design means so already existing design should be modified with the different methods and materials. This is the developmental design, right? Now a new design, that means here the designer develops entirely new products. That means there is no copy or no existing, there is no changes in the existing one. It means system in which is not existing earlier. That means that the designer develops entirely new product. That means simply vacuum cleaner here in this case. These are the three methods. Number one is the adaptive design with the minor alterations and minor modifications, and the new developmental design is completely, not completely, but the obsoleted products can be modified into different methods and different materials. And whereas the new design is designer develops entirely a new product, right? So these are the three methods used for machine design or mechanical engineering design, right? Now let us have the different factors for the design. Say factors means you have to design any products, we have to think different parameters or factors for the design. Let us say suppose there is a pen you want to design. It may be an existing one, or it may be new one, or it may be developmental, whatever it is. But here in this case we have so different factors. Its appearance, what in what its aesthetic appearance also we should have to take into account. That is one of the factor, and its weight, and also its performance, and its material. The materials may be of different types, and also its cost. Any person needs with low cost and good pen, and its durability, and any customer requires more durability, more life and reliability also. These are the some factors in case of design of a pen. Similarly, for design of any machine or any product needs different factors for its design. So let us see what are the factors we have to take into account for the design of any product. Let us see, here are the factors generally we use for the machine design or mechanical engineering design. The factors to be considered in machine design. Number one factor is, there may be other factors also, but here are the most important parameters or the factors. Here are number one, nature of load, number two, working stress, and number three, mechanical properties of materials of the product, and next is process of manufacture, and next is reliability and durability, next is cost, and also life of the product, and also safety. Let us see, nature of load, and also another factor is also there, mechanism is also another factor, and working stress, and mechanical properties of materials of the product, and process of manufacture, and reliability and durability, cost, and then life and safety. These are the some of the factors we are going to take into account for the design of any product. Let us see each one. Nature of load. Generally, what is meant by load? Load is nothing but, load is the external force acting on a component or the product or the body. So external force acting on the machine part is called a load. That means indirectly, so this may load, this the load may be a dead load or steady load, and live load or variable load, and suddenly applied load, and shock load or and impact load. These are the different types of loads are there, and some other types of loads are also there. They are the point loads, uniformly distributed loads, and uniformly varying loads also there. Here in this case, dead load or steady load, live or variable load, suddenly applied load or shock loads, and impact loads. Whereas some other loads I told you already, point loads, uniformly distributed loads, uniformly varying loads. These are the different types of loads. Now stresses, in case of stresses, that means working stress. In case of working stress, before that let us have the definition for stress and strain. The stress is the load per unit area. The definition for stress is load per unit area, where the strain is change in dimension by original dimension. It is the ratio between the change in dimension by original dimension. Now let us see, various stresses are there. Various stresses are there. Number one stress is tensile stress and correspondingly tensile strain, and compressive stress and correspondingly compressive strain, and shear stress and correspondingly shear strain also, crushing or bearing stresses, etc. These are the different types of stresses are there. Now let us see design stress or working stress. So let us see, design stress is the a value used in mathematical calculations for the required size of machine number. Now, to calculate a machine number size, we are going to use mathematical formulas. In such case, we are going to use the value that is called design stress. And the working stress is generally the design engineer should have sufficient knowledge in assuming and in taking design stress, proper design stress value. Now here in this case, next is working stress. Stress actually occurring under operating conditions. That means under operating conditions is different, whereas the calculation value is different. So stress actually occurring under operating conditions. The working stress is equal to working load by cross-sectional area. This is the definition for working stress. And sometimes we use design stress as the working stress also. In some of the areas, whenever separately they are not given, generally we use working stress itself as the design stress. Now next is factor of safety. Factor of safety is the ultimate stress. Ultimate stress, let us have the definition. It is the maximum value beyond which the material may get breakdown. So it is the maximum permissible value. Whereas the factor of safety is the ratio between, is the ratio of ultimate stress to the design stress or yield stress to the allowable stress, whatever it is. So here the design stress, factor of safety is ultimate stress to the design stress. So its value, the selection for a factor of safety mainly depends on the material required or the material selected for the manufacturing a component or the products, and the type of load acting on the component or the machine element, machine part, and working conditions. It means material selected, type of load, and working conditions. These are the three main factors on which the selection of factor of safety depends. And next is, suppose here are some examples. Based on the type of load, the factor of safety values are ranging from 3 to 4 for steady load and 6 to 8 for varying or reversal loads, and 9 to 16 for shock loads. Once again, you must remember here these values: 3 to 4 for steady loads and 6 to 8 for varying or reversal loads, and 9 to 16 for shock loads. Now let us see mechanical properties of materials of the product. Here are the, and it is one of the most important factor. That means selection of material. In case of selection of material, and also mechanical properties are one of the most important parameters or factors, very important factor based on which the entire strength of the product depends. So various mechanical properties of materials are: number one, strength, ductility, brittleness, malleability, hardness, toughness, fatigue, and resilience. Let us have the definitions for strength: resistance to deformation or resistance to change its dimension; ductility, ability to deform under tensile loads; and brittleness, uh, resistance to deform; and malleability is the ability to deform perpendicular to the axis, that means under compressive loads. Whereas hardness is the resistance for indentation or scratching, whatever it is. The toughness is ability to store energy up to fracture, and fatigue is repeated and reversal loads. That means fatigue is the resistance to repeated and reversal loads, whereas the resilience, ability to store the energy per unit volume. These are the definite: strength, ductility, brittleness, malleability, hardness, toughness, fatigue, resilience, and also creep, slow and progressive deformation of the member. These are the different mechanical properties we are going to use, which are that means the selection of proper material depends on. Now the type of materials, there are so many engineering materials are there. Here see metallic, and non-metallic materials are there. Non-metallics, here you can see plastics, rubber, wood, ceramics, and asbestos, etc. These are the plastics, rubber, wood, ceramics, asbestos, etc. comes under the non-metallic materials. Whereas in case of metallic materials, here you can see ferrous metals and non-ferrous metals. Ferrous metals means containing carbon percentage, whereas non-ferrous materials, there is no carbon percentage in the materials. So in case of ferrous metals, wrought iron, steels, and cast irons. In case of steels, carbon steels, alloy steels. You can see here in this case alloy steels and heated and corrosion resistant steels, and also wear resistant steels and high strength steels, and tool steels also there. These are the ferrous materials you can see. Whereas in case of non-ferrous materials, aluminum and its alloys, copper and its alloys, lead, tin, nickel, and zinc, etc. Here in this case, in every case, wrought alloys, cast alloys. In case of wrought alloys, say aluminum, copper, silicon, manganese, and etc. alloys. Whereas cast alloys, aluminum, silicon, magnesium alloys, etc. And whereas in case of copper and its alloys, in this case you can see brasses, tin, bronzes, and aluminum bronzes, etc. You can see in case of brasses, cold working, hot working methods, and in these two methods you can create, manufacture a brass material combinations. And these are the different engineering materials, mainly divided into metallics and non-metallics, and metallics are divided into ferrous and non-ferrous, and then these are the different materials you can see. And now is the process of manufacture, and also one of the important parameter out of the factor that we have to consider for the design of any products, and another vital factor on which the design of the product depends. Here are the various process of manufacture of a product are casting, and next is mechanical working. In case of mechanical working, cold working and hot working techniques are there. Machining, there are so many machining techniques are there, lathe machining and milling machining, drilling, and etc. And you can see forging, forming, and non-conventional machining process. In case of non-conventional machining process, you can have many different techniques are there, right? So now, and another is reliability and durability. What is reliability? Ability of a product to perform required function under given conditions for a specified period. That means here you can see ability of a product to perform a required function. Here you can see required function under given conditions for a specified period of time. Required function, specified period of time. That is the reliability. Whereas in case of durability, resistance against environment. That means environment majorly plays a major role. Mainly, environment plays major role. In such case, we have to take this environment to account also. So, resistance against environment and also use and maintenance over a specified period. First one is the reliability, that is required function, specified period, whereas durability, resistance to environment, use, and maintenance. Some people may maintain in different way. In such case, the durability may be less, whereas some people may use carefully. In such cases, the durability may be more. So that's why durability depends on environment, use, and maintenance, whereas reliability depends on required function and specified period. These are the reliability and durability. This is also another important factor I have to take into account, right? So next is the cost. Let us see cost. Majorly, another important parameter or the factor here is the cost. And cost and quality of a product are interrelated. If the quality increases, cost also increases. If the quality decreases, cost also decreases. Some people customer requires good quality with low cost, whereas the manufacturer wants to produce low quality, high cost. Where the customer needs high quality, low cost, where the manufacturer needs low quality, but it should be optimum. That means cost must be optimum, which may be affordable to the manufacturer as well as the customer also. That's why the cost determination is one of the major and important factor we have to take into account, right? And next is the product must be acceptable quality at a minimum cost. So this is another factor, right? Next is life of the product. So number of times the product is operated before failure. So many times are operated, so many times before failure of any product. So it has to withstand all its maintenance, use, etc., and also environmental problems, and it has to withstand for more number of times, useful for the more number of times. So next is unnecessary length of time. A product increases cost of the product also. That's why life of the product is also another important parameter, right? And last one is safety. The safety is also last important and most useful factor, that is, and machines are potential danger to the operator and equipment. That means the safety must be there for the operator as well as for the machine also. Designer must ensure that the design is safe in operation. So safety is also another parameter that you must remember in this case. These are the some of the factors, and also mechanism is also another factor. Mechanism is also another factor, and some more factors are standardization, assembly, maintenance, appearance, and market needs. So once again, let us see the factors. So nature of load, and another parameter is also there, mechanism and working stresses and mechanical properties of products, and selection of materials is also one of the important parameter, and manufacturing process is also another important parameter, reliability and durability, cost and life of the product, and the safety also there. And another parameter is shape and size also there. Shape and size here in this case they are not given, we are not taken into account. And another parameter is shape and size. And in case of selection of any design, some products are heavy sizes. This is for example ships needs to bring all the machinery to the manufacturing site, whereas some small products are there which may be manufactured within the shop floor itself. So another parameter is shape and size of the product, right? And next is mechanism, and which mechanism we have to use in this case. That is also one of the important parameter. That means every mechanism will give you proper motion to the product, proper motion to the product. That is also another parameter, right? So once again, let us see the factors to be considered for the selection of a product. Number one is load, number two is mechanism, number three is working stresses, number four is selection of materials. In case of selection of materials, mechanical properties are also one of the important factor, and also manufacturing process, and shape and size, reliability and durability, cost, and life of product, safety. These are the different factors we have to take into account for the selection of proper material and for the design of any product, for the design of any product. So along with this, some other parameters are also there. They are standardization. That means standardization means it should have interchangeability. The parts manufactured or the products manufactured must be standardized to interchange. And also assembly consists factors. Maybe some products may need assembling at one site, and another is some products need within the shop itself. And maintenance also another factor, and appearance and market needs also another factor. And now totally finally here in this case you can see mechanical design is the a creation part of engineering, application of many principles of science and technology to fulfill the desires of human being. This is the mechanical engineering design or machine design. Say, let us see the design in case of design factors. If you want to design a car, so here in this case, you have to take first of all its shape and size, cost, material, safety, performance, appearance, reliability, and durability. And while designing a product, detailed study, systematic analysis, use of relevant technology are very essential factors. Now let us see some of the quiz questions. Manufacture of bullock cart falls under the which category? That means here are the traditional design method, design by drawing, and none of the above. As we have seen the theory itself, it is the traditional design method. Bullock cart is the traditional design method technique. And another is an important consideration of design and machine part is strength, manufacturing process, and material. All the above. All the above strength is required for design of any component, and manufacturing process is also important parameter. Material is also important. That's why here in this case, D is the answer. All the above are needed. Right? Next is capacity to resist the action of external force on a member is called stress, strength, strain, and hardness. See here, capacity to resist the action of external force. That is the answer is B, strength. So once again, let us see review totally. Once again, let us see. Now the design, formulating a plan for achieving a useful product, right? And the next is what is the need? Why we have to design? The human needs are the one factor, and the desire of human and the ambitions of human leads to design of a new product or maybe a existing product to be developed. Next is, since its evolution, human needs food. That's why he started producing hunting tools and also boating, etc. for fish like movement, and also developed means of water transports, and developed for lifting techniques, and developed air means, road means, and water means also. And also here you see the design techniques are two types: design by craft evaluation, design by drawing. And also craft evaluation, here are the examples are bullock cart, rowing boat, plows, and musical instruments. So in case of craft evaluation, the main features are no drawings are there. That means no proper size and shape. As per the requirement, only they will produce the components. So no dimension drawings are of products, an adequate justification for design, and the products developed by only trial and error method. That means repeatedly they will try, and finally if you satisfy, then only that will be final product. And next is no medium to record manufacture and assembly techniques in this craft evaluation. Now here in this case, design by craft evaluation becomes obsolete nowadays with nobody using obsolete techniques. That means craft evaluation, but nowadays for anything we are going to have drawings, so it is obsolete technique and leads to development of design by drawing. And design by drawing consists of the main salient features are drawings are developed prior to manufacture. Intellectual activity, that means scientific designing, is assigned to design engineers. Trial and error are conducted at drawings instead of shop floor. Manufacturing process is subdued in different areas. So design by modern machine design was developed on the foundation of design by drawing. So in this case, machine design means simply creation of new and better machines, creation of new and better machines, and improving the existing one, improving the existing one. This is the machine design. Machine design is intended for you to develop a products which are safer to the human, more efficient, comfortable, economical. The main intention or the main design is safe, efficiency, comfortable, economical. So definition for the design is formulating a plan for producing a new or existing product by using scientific principles, technical information, imagination, that means drawings of machine or system, whatever it is. That is the definition of machine design or mechanical engineering design, right? So in case of machine design, we need the concepts of mathematics, engineering mechanics, that means machine physics principles, the strength of materials, theory of machines, and workshop technology. All these concepts are required for designing any component in case of machine design. So machine design develop products to perform specified functions with maximum efficiency and economy, right? And the classification of machine design are the three categories. Number one is adaptive design. That means already existing design is slightly altered or modified. Whereas the developmental design is they will modify the methods or materials, whatever it is. And new design is completely new one, right? Designer makes minor alteration, modification in the existing design of the product, right? And the developmental design modify the existing designs into a new by adapting new material and different method of manufacture. And the new design is designer develops entirely new product or system which is not existing earlier. These are the three types. One is adaptive, new, developmental, and new designs are there. So factors are, let us see, these are the factors. Along with this, there are some other factors also there. Load, mechanism, working stresses, selection of material, mechanical properties, manufacturing process, shape and size, reliability, durability, cost, life of the product, and safety. These are the factors to be considered in machine design. So load is nothing but the external force acting on machine components. So loads are different types are there. Number one is dead load or steady load, live load or variable load, suddenly applied load or shock load, impact load. And also another types of category are point load, uniformly distributed load, uniformly varying load. Now, the stress in case of working stress, there are mainly the stresses are tensile stress, stress induced in a body due to tensile load. That means which tends to elongate the body. The strain is tensile corresponding to the tensile stress, strain corresponding to the tensile stress, compressive stress, shear stress, crushing or bearing stresses. And design stress is the value used in mathematical calculations for design of a machine member to have the different size, required size. And the working stress is stress actually occurring at under operating conditions. So working stress is equal to working load by cross-sectional area. And ultimate stress, it is the maximum permissible value beyond which the workpiece may broken, right? And factor of safety is the ratio between ultimate stress to the design stress or also yield stress to the permissible value, permissible stress, allowable stress. And the selection of factor of safety mainly depends on material selected, type of load, working conditions, and also based on different types of loads, it is 3 to 4 for steady loads, 6 to 8 for varying or reversal loads, 9 to 16 for shock loads. And the mechanical properties of materials and the selection of material is one of the important factor on which the strength of the product depends. That's why the proper material is to be selected based on the mechanical properties. The mechanical properties are strength, hardness, ductility, toughness, brittleness, fatigue, malleability, resilience, and creep, etc. are there. And castable properties may be also there. They are the machinability, castability, weldability, another also factors are there, properties are there. And types of materials are mainly metallic materials, non-metallic materials. In case of metallic materials, ferrous metals are there, non-ferrous metals are there. And now manufacturing process, another important factor, that is manufacturing techniques are casting, mechanical working of metals by cold working, hot working, and machining techniques are lathe, milling, shaping, slotting, planing, broaching, etc. Machining, different machining techniques are there for manufacturing a product, and also forging another technique, forming another technique, and also powder metallurgy and non-conventional machining process are there. Under reliability and durability. Reliability, ability of a product to perform required function under given conditions for a specified period of time. And durability is the resistance against environment, use, and maintenance over a specified period. And cost and quality of a product are interrelated. The products must be acceptable quality at minimum cost. And life of a product, next factor, number of times the product is operated before failure. Unnecessary length of life of a product increases cost of the product. And safety, machines are potential danger to the operator and equipment also, and design must ensure that the design is safe in operation. These are the different, along with these factors, standardization, assembly, maintenance, and appearance and market needs us. All these are the factors. So, friends, let us close this session with this conclusion. Thank you, one and all.